So for this one, we're looking at a composition of functions. We're taking f and we're going to compose it with g, and then we're going to find that domain. So first, we have to make sure we understand the definition of f composed of g. So I'm going to use the colors to signify this. So f will be in green and g will be in purple to help, hopefully. So we're going to see f of composed of g of x. So this is defined as f of g of x. Okay. And so let's go ahead. We're going to be basically seeing, we're going to plug in g of x into f. So this whole function, this expression, is going to be plugged in just for that x term. So our outer function is 1 over, and then we're going to put a nice big parenthesis there, then minus 2. And in the parentheses is where we're going to put g of x, 1 over x plus 3. All right. So we're going to go ahead and find that LCD because it's a complex expression. So for this LCD, it's easy to just multiply top and bottom by x plus 3. So that's what I'm going to do. So when I do that, I'm going to distribute it to both terms on the bottom. In the numerator, there's only one term, so when it gets distributed, it doesn't look like much. It's just 1 times x plus 3. On the bottom, I have 1 over x plus 3 multiplying to x plus 3, and then minus 2 times x plus 3. And so we get then x plus 3 over, and the whole goal was to get rid of that complex expression, and we do. So this becomes an x plus 3, or no, sorry, the 1. There we go, 1 minus, and now distribute the negative 2 through. That becomes minus 2x minus 6. Okay, combine 1 and negative 6. And so that you get, 1 second, I'll shift you up, there we go. And so we get then x plus 3 over negative 2x, then minus 5. Okay, so that's the composition. So we can go ahead and box that. Okay, but the question is to find the domain. So we're also going to find the domain on this. Now, it's important to understand that our domain, the way it works, is I have the domain of g of x, which is the x terms. It goes into g, and here is all of the g of x terms. Okay, so g takes values of x and then has its range g of x. From there, f takes values from g and then creates its range from there. Okay, so that's the idea. So that's what we're looking at. So the important thing is to understand that we need values in the domain that are real, okay, for their range. So it comes back as a real value back when I plug in it into g of x, or the inside function. So it's important to take into consideration the inside function's domain, because if it doesn't make sense when you plug it in, when you try to plug it into f, you're plugging in something either non-real or undefined. You can't do that. So we immediately look at the domain for g of x. Okay. Once we find the domain of g of x, we also have to take into consideration the for the expression that we have for the composition. So the composition has to make sense in the end as well. So when I look at the composition, I have to consider what values would make this undefined or not real. So first, let's consider g of x. So g of x is 1 over x plus 3. So the denominator, if it equals 0, is undefined. So that means for g of x, we have to say x plus 3 cannot be equal to 0. So that means x cannot be equal to negative 3. So that means that we're kicking out that value. Then we have to have and. So this is an intersection of two sets. And the composition can't have anything undefined or not real. So when I look at that one, that composition here, we can see that we have that denominator with a variable. So I need to find when this, again, set that this cannot be equal to 0, because if it's equal to 0, it's undefined. So we're going to go ahead and say negative 2x minus 5 cannot be equal to 0. So we have negative 2x cannot be equal to 5. So x cannot be equal to 5, negative 5 halves. And so these are the two things. So this is true and this has to be true. So when I create my domain, I start off with the smallest value, negative infinity, and I go to the next small value to negative 3. And this is where I have to create that hole around the negative 3. And then I go up to negative 5 halves. And then create the hole around negative 5 halves, and then off to infinity. And there, that is how we find our domain.